Hi friends, this video we are going to solve one optimization problem using steepest descent method. So this method is only applicable for unconstrained optimization problem. So they will give the initial point also. So it is a iterative process. So first step we are going to define. So what is the algorithm is? We are going to find x n plus 1 equal to x n plus lambda n star times s n. We have to find. So what is Sn? Sn equal to minus times gradient of f of xn. So we have to find this lambda star is optimum lambda n we have to calculate from the further function. So this is the iterative process. The stopping criteria is you want to fix some epsilon value. Epsilon is here some positive value. So you can find gradient of f of xn is less than epsilon, means we have to stop this method. So in this problem they given the function f of x1 comma x2 equal to x1 minus x2 plus 2 times x1 square plus 2 times x1 x2 plus x2 square, and the initial vector is 0 0. So first we want to start with the iteration 1. So first step I want to calculate what is the gradient of f. What is the gradient of f? Dou f by dou x1 dou f by dou x2. So dou f by dou x1 is 1 minus 0 plus 4x1 plus 4x1. This is plus 2 times x2. This is 0. So second component is you want to take derivative with respect to x2. So you get the minus 1 plus 2 times x1 plus 2 times x2. So this is the gradient. So first step I want to find the S1. S1 equal to minus times gradient of f of x. So this is nothing but minus times gradient of, so xn minus 1. So gradient of f of x0 is the given vector is 0 0. So I want to put it as 0 0. So this value equal to so put means only you will get it as minus times minus plus 1. Here you will get the minus 1. This is the S1. So what is the x? Sorry, this is x naught. This is x. So here it's x naught only. Sorry, this is x naught. Here xn only. Sorry for the confusion. X. So x2 equal x1 equal to x naught plus lambda naught star s naught. I want to do it. What is the x naught? X naught is 0 0 plus lambda star. Naught star is you kept as it is. We have to find s naught is, now only we find minus 1 plus 1, because minus times 1 is minus 1. So now you want to find the f of x1. So f of x1 means, so this value is, we will get it as minus times lambda naught star plus lambda naught star. So the first component is lambda minus lambda naught star, second component is lambda naught star. So we will get it as minus lambda naught star minus lambda naught star plus 2 times x1 square. So 2 times lambda naught square minus 2 times plus 2 times x1 x2. So minus 2 times lambda naught square plus lambda naught square. So this guy and this guy will cancel out. So it's become lambda naught star minus square minus 2 times lambda naught star. So now this is a function of lambda naught. So d of x1, that is d of d lambda naught star equal to 2 times lambda naught star minus 2 equal to 0. This implies lambda naught star equal to 1. So this is the optimum value for the lambda naught star. Now I want to fix it, x1 equal to x naught plus lambda naught star of s naught value is minus 1 plus 1. So next is, I want to find the, this is my x2, x1. Next step, I want to find the second iteration. You look, the gradient of f of x naught is not equal to 0. So that meaning is you want to do further also. Second step, I want to, this is go for the iteration 2. Iteration 2, what I want to find? Again I want to find grade S2 is the, S1 is the my next step, minus S1 is minus gradient of f of x1. So minus times gradient of f is, I already calculated the gradient of it, that's not going to change. So 1 plus 4x1, 1 plus 4x1 is minus 4 plus 2x2 plus 2. So second is minus 1 minus 2x1, so plus 2x1, so minus 2 plus 2. So this value is nothing but minus 1. Here you will get it as a plus 1. This is the, so minus outside will be there. So this is f1, this is not equal to 0. So this implies this gradient is not get the optimum value. We know that. So okay, this is our stopping criteria, that is why. So I will go for the x2. x2 equal to x1 plus lambda 1 star times gradient of f of, sorry, s1 I want to find. So again I will apply x1 is 1 minus 1 plus 1 plus lambda 1 star, this one is plus 1 and minus 1 will come. So we will get it as lambda 1 star minus lambda 1 star. So this implies minus 1 plus lambda 1 star 1 minus lambda 1 star. So again I want to find the f of x2. So f of x2 you will get it as 5 times lambda 1 star square minus 2 times lambda 1 star minus 1 we will get it as. Now this is become, now it's a function of lambda 1 only. So df by d lambda 1 star, you will get as 10 times lambda 1 star minus 2 2 equal to 0. This implies lambda 1 star equal to 1 over 5. So our x2 become minus 0.8. Here is, you will get it as plus 0.8. So please do the calculation. Here it's minus. Yes, here also minus only will come. Look, minus 1 minus 2 plus 1 minus 2 is minus 1. So we will get here minus. Sorry, here also minus. Please correct it. And here also minus. So this guys become minus 1 by 2. Sorry. Here only plus will come. Here it's minus. 1 plus will come here. Please change it. So we'll get it as 1.2. So again you will do the process, same process again and again. You will get the final answer. Okay, you can do the next step is, you want to third iteration, you will proceed. So gradient of f of x2 equal to minus 1 plus 4 times x1, so minus 3.2 plus 2.4, here is minus 1 plus 2x1 is minus 1.6 plus 2.4 you will get. So this guy value is 4.2, so minus 1.8, so 0.8, so we will get it as minus 1.8. Here you will get it as minus 0.2. So this is not equal to 0, so we can proceed again the same process. Okay, I hope you understand. I didn't solve the problem fully, but I give the 2 iteration only. Okay, I hope you understand how to solve given unconstrained problem using steepest descent method. Thank you for watching this video.